All right, so again, 6-1 quadratic functions. A quadratic function is y equals ax squared plus bx, or f of x equals ax squared plus bx plus c. Okay, the a is a coefficient, b is a coefficient, and c is the constant. We're going to talk about what each of these mean and how you use each of these to graph a quadratic function. Now, of course, when you have a quadratic function, you need x to not equal 0. If x equals 0, you're going to have what's called a linear function. Okay, if x were to equal 0 here, that would be 0, that would be 0. Y would equal c, which is a linear constant function. So x cannot be 0. And in fact, a cannot be 0 either. Because if a is 0, then I get rid of the x squared, and that means that I'm left with y equals bx plus c. Or in other words, y equals mx plus b. So you would have a linear equation. So neither x nor a can equal 0 in a quadratic function. Now, the quadratic functions produce U-shaped graphs. And these U-shaped graphs are called parabolas. Okay? Now, there's a lot of stuff to this parabola, so I'm going to do my best to break it down, okay, one by one. Now, first of all, a and b are coefficients, and c is the y-intercept, which is a constant. When you have a quadratic function in the form of f of x equals ax squared plus bx plus c, you can immediately eliminate the x's and be left with the c. Well, guess what? That's the y-intercept. How does that work, Mauro? Well, the y-intercept, isn't that the y value on the y-axis when x is 0? So if I have x is 0 here, my y-intercept would immediately be c. Now, it doesn't always work like that. We're going to see a different form of the quadratic function that's called a vertex form. Not today, but later on in the chapter. And in the vertex form, you're still going to have a constant c, but you cannot call that the y-intercept. All right? The y-intercept only works in this case being the c. But if it's in any other format, it's easy to find the y-intercept. Make x 0, solve for y. That's the y-intercept. Okay? Now, let's talk a little bit about the a. If a is greater than 0, then the graph opens upwards. If the a is greater than 0, I don't care if it's 0.000000021 or 5 billion. If it's greater than 0, if it is a positive, it will open upwards. Now, a lot of people always teach it like this. Okay, guys, so it's going to be like this. They're right. It will open upward, but that is not the only type of parabola you can have. You can have a parabola over here, opening upwards. You can have a parabola over here, going through the x-axis, opening upwards. You can have one over here, opening upwards. You can have one over here, not going through the origin, opening upwards. So the placement of the parabola is not determined by the a. No way. All the a is telling you is saying, hey, reader, listen up, fool. It is going to point up. This u is going to open upwards. It's going to go up. And if you notice, each leg of the u, it's not going straight up and down, guys. It's not. Okay? It is slanting ever so slightly. This one is little by little, it's increasing, increasing, increasing. So the x is increasing. And to the left, it's also, the x is decreasing. Does everyone see that? They're not going straight up and down like a U like this. No, that's not the way to do it. Absolutely not. It's a nice curvature. And it keeps going out both towards the right and towards the left. Does that make sense, boys? Promise? On the converse, and look at how I did this wrong. I apologize. My bad, my bad. I will fix this right now. Okay? I will fix it right now. I'll just do it here. Okay, sorry about that. If A is less than 0, then the graph opens downwards. So we're looking at a graph that's going to look like this. Or one over here that's pointing down. Or one over here. Or one over here. Again, all the A is telling you is, hey, reader, this graph is going to open downwards. So right there off the bat, even if you don't get the right parabola, you're going to at least know on your homework and on your quizzes and on your tests, okay, I at least know it's pointing up, so I know I'm at least going in that direction. And also, this is extremely valuable for the SAT. I don't know how many times I've solved quadratic equations in the SAT by just looking at the A. I have actually seen SAT questions that say, graph 2x squared minus 5x plus 2. And they'll have 3 of the 5 choices pointing down. Immediately, those are gone. And then I'm going to show you other tricks on how to identify it. But even if you knew nothing else about the math, you had no idea what the vertex was or the axis of symmetry, and we're going to get to all of that, right off the bat, you can get rid of 3 of those. Because you know it's a positive, so it's going up. So if you see graphs that are going down, scratch them out, scratch them out, scratch them out, because that's worthless. They're wrong. So that's one good little trick, hint. It's a helpful thing. May I continue? Okay, now, the C we had already mentioned, but I'd like to mention again, I want to make sure you guys are completely understanding this. The C is the y-intercept. It is the y value when x equals 0. So in other words, plug in 0 for all x values and solve for y. That's what the y-intercept is. And that's what the c is in the quadratic function y equals ax squared plus bx plus c. If you don't remember that the c is the y-intercept, that's fine. Plug in x is 0 for all the x's, and you're going to solve for y. Now, parabolas are symmetrical. Now, symmetrical, you may say, oh, I think I know what that is, but I'm not really sure. Symmetry is when you have 2 equal halves. You guys remember when you were kids, little kids, and it was like Mother's Day or something, or Valentine's Day, and your teacher wanted you to make a perfect heart. Didn't she make you fold the paper and then draw 1/2 and then cut that and then open it up and both halves were exactly the same? Well, you created a symmetrical figure there. Symmetrical means that you can cut it straight down the middle. And that straight down the middle is called an axis of symmetry. So if you were to put a ruler right in the center, in between your eyes, cutting your nose in complete half, your face is more or less symmetrical. All right? So, parabolas are symmetrical. The line that cuts a parabola into perfect symmetrical halves is called the axis of symmetry, which is an invisible vertical line found by using the formula x equals -b over 2a. The axis of symmetry is an x equals equation. So that means that it is going to be a vertical line. What the hell is this man talking about? Let's say that I have this graph here. Okay. The axis of symmetry in this particular case would be right here. And that's an x equals equation. Now, why is the line of symmetry? Because this point is 1, 2 to the right of the axis. Well, guess what? 1, 2 to the left of the axis, you have a point again. They're completely symmetrical. All the points on this side are going to be mirrored on the opposite side of the graph. They're mirror images. Okay, that's the axis of symmetry. Now, how do you find the axis of symmetry? Remember the formula y equals ax squared plus bx plus c? Plug it into this formula here. X equals negative b over 2a. That will tell you where the axis of symmetry is. That will tell you the line that is cutting it in perfect half. Does that make sense, guys? You sure? Yeah. So, again, I could have one going down. Like, let's say in this case, look, check it out. I have this right here. In this case, what is the axis of symmetry? Isn't it the y-axis? Yeah. So in this case, my axis of symmetry is the y-axis, or x equals 0. Why, Moro? I don't get it. Because I am cutting it in perfect half here. Okay, I'm cutting it in perfect half. The line that cuts the parabola in perfect halves is called the axis of symmetry. Is everyone with me so far? So far we know that a parabola is a U-shape. The standard function is y equals ax squared plus bx plus c. The a, if it's positive, that means it's going to open upwards. If the a is negative, it's going to open downwards. The c is the y-intercept. In other words, the y value when x equals 0. The axis of symmetry is the line that cuts the parabola in perfect half. And you can find the axis of symmetry by following the formula negative b over 2a. Does anyone have any questions so far? Because this is the kind of chapter where if you don't get it today, you're done. I'm not threatening you, but if you don't get this today, if you don't understand every single concept I teach today, you're going to be very, very lost the rest of the chapter, my friends. Yes, sir. Y equals ax squared minus plus bx plus c. It's negative b, whatever the value of the coefficient of x is, divided by 2 times the coefficient of x squared. Thank you, sir. You're welcome.
So when you,
yes, sir?
when you find
the axis of symmetry?
just plug it back in.
No. No, that's not what I said. Please do not put words into my mouth. No. Absolutely not. Scratch what he just said, please. You are going to plug it in, but that does not find the c. You find the c by making the x 0. Please, please don't make that mistake. Thank you so much for your honesty. May I continue? All right. Now, vertex. The vertex of a parabola, okay, determines the maximum or minimum values of the function. In fact, let me go back for 1 second. Hold on. Wait, sir, hold on. See this point here that I'm marking in blue? Isn't that kind of like the swivel point? Isn't that the point that's going to determine either I'm going up to the right or up to the left? It's the swivel point, right? If I'm going from left to right, I'm going down, down, down until I get to this blue point. Then I'm going up, 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 right? This is called a vertex. This one over here is called the vertex as well. The vertex is on the axis of symmetry, and it is the point that is going to determine either a minimum or a maximum. When A is greater than 0, when A is positive, when the parabola is pointing up, my vertex will always be a minimum. When my vertex is belonging to a quadratic function whose A is less than 0, whose A is negative, the graph is pointing down, the vertex in this case would be a maximum. Okay? Now, sir, you had a question, my brother.
You said to find C, you leave x 0, but
Correct.
x can't, at the beginning you said x can't equal 0.
Okay. If I tell you graph this quadratic, the question was to find the y-intercept, you make x 0. But you said that x could not be 0. Yes, x cannot be 0 to graph a quadratic function. But are we graphing the function? That we're finding one point of that function. We're finding the y-intercept. The y-intercept is the y value when x equals 0. Now, if I write the equation 2x squared plus 4x minus 6, but x equals 0, well, then I have just y equals negative 6, and I'd have a horizontal line. That's what I'm saying. Thank you so much, sir. You're welcome, my brother. So, back to the vertex. The vertex of a parabola, like I said, determines the max or the min values of the function. And it's found by using the formula. Okay, this is a lot easier than what it looks like. The negative b over 2a, that's the axis of symmetry. So once you find that x value, plug that x value into the original equation and find the y value. That's what you meant, but that's not what you said. Okay? So find axis of symmetry, all right, which is an x equals negative b over 2a. Then plug in axis of symmetry into function, comma, to find the y value. The y value. So once I find my axis of symmetry with negative b over 2a, I plug that sucker into the equation. Now I know what my y value is going to be for that particular x value, and now I have my max and or min. And I wrote it down here. I don't even know why I wrote it in red. Simply plug in the value of the axis of symmetry, x equals negative b over 2a, into the quadratic function and solve for y, aka also known as f of x. Okay? I'm taking my time here. This may even take 2 days to finish teaching. I don't care. I'm fine with that. What I need to make sure you understand is everything that we've done so far. So far, you should know that if you have y equals ax squared plus bx plus c, if you have an x squared there alone, you're going to have a quadratic function. Quadratic function is a U-shaped graph. If the a is greater than 0, it's opening upwards. If the a is less than 0, it's opening downwards. The line that cuts the parabola into perfect half is called an axis of symmetry, and it is found by using the formula negative b over 2a. Once I have my negative b over 2a, I plug that x value into the equation, and I find my y value. And now I have what's called the vertex. Is everyone with me so far? Again, I'm not threatening you. I'm telling you as nicely as I possibly can. If you don't get this today, not tomorrow or next week or in 3 weeks from now, but today, you are going to be hurting for the rest of this chapter. So are we cool so far? All right, my brothers. Now, I just repeated this, but let's go ahead and check it out. If a is greater than 0, then the graph opens upward, and there will be a minimum. So again, if I have a graph and it's like this, this will be my vertex, and that is a minimum in that particular case. When a is less than 0 and the graph opens downward, then there will be a maximum. That will be my vertex, which is a maximum. Yes, sir, and yes, sir. You cannot have a maximum and a minimum in a parabola, because then you'd have to combine the bottom part, and it would no longer be a parabola, sir. Good question. Yes, sir. I found the axis of symmetry, which is the negative b over 2a, and I plug that value into my function. F of x equals y, right? But what am I replacing the x with in this case? No, the negative b over 2a. It's a negative b over 2a. Look, son. I have y equals, we'll make it easy, x squared minus 4x plus 2. The axis of symmetry is going to equal negative b over 2a, which in this case is 2. So my vertex will equal 2, because that's the x value, negative b over 2a, and you plug that 2 into the function. 2 squared is 4, minus 8 is negative 4, plus 2 is negative 2. Now I have my vertex. I find the axis of symmetry, which is an x equals value. I plug that x value, that axis of symmetry, into all the x values of the given function. And then I solve for y. This is my first value, my axis of symmetry, negative b over 2a. This is f of x, but what am I replacing the x with? Negative b over 2a. So I have to plug the x back into the equation and find the y. Does that make sense, my brother?
No, not really.
Why not? How does that not make sense? How does that not make sense? How? Negative b, negative times a negative 4 is 4 over 2a. What is the a here, son? What is 4 divided by 2? 2. Is the vertex not negative b over 2a? What is my negative b over 2a here? 2. Did I not plug 2 into this function? So what don't you get? 4 minus 8 is negative 4 plus 2 is negative 2. Find the axis of symmetry, plug it into the equation for every x, and you're going to get a y. That is your vertex. Talk to me, son. This is what I wanted. I thank you for your honesty.
No, I understand.
Are you sure, my brother?
Yeah.
Does everyone understand this? Yes, sir.
Would the factoring come in place?
Factoring is going to come in place later. Let's walk before we run, please. Yes, sir.
So the axis is true, the line
where x equals 2?
Correct. We're going to go through the whole process in a second, guys. You guys are you're stressing out for nothing. Right now, all I want to go is step by step. And I'm going to show you how to put it all together, I promise, okay? Thank you, though, sir. Does that make sense so far, gentlemen? Yes, sir. 2, negative 2 is the vertex. That's going to be, in this case, it's going to be a minimum because A is positive. Guys, this is my axis of symmetry. Well, not in this case, but that's the axis of symmetry. That's the negative b over 2a. When I plug in the negative b over 2a, that x value, into the original function, I'm going to get a y value. Those 2 points are called the vertex, which in this case is a minimum. Because if the graph opens upwards, you will always have a minimum. This over here, this again is the axis of symmetry. It cuts the parabola in perfect halves. This up here is the vertex. It's on the axis of symmetry. It's that y value at the axis of symmetry x value. And in this case, it will be a maximum because whenever a is less than 0 or whenever the quadratic function points downwards, I have a maximum. Thank you, sir. Does that make sense so far? Are you sure, gentlemen? Okay. Now, what does the graph of the quadratic function y equals x squared look like? What are the significant parts of the parabola? Let's go over this. When you're graphing, try to graph as neatly as possible, gentlemen. So I'm going to do my best as well. Make sure always that it's a nice curvy U. Please do not do this. I will not accept that. Thank you. I heard Jacob say that's absolute value. That's exactly right. If you do a straight up V like this, guys, with all due respect, I will mark it wrong because it is wrong. I don't need you to be Vincent van Gogh. I'm a horrible artist, but you can tell clearly that it's a rounded bottom there, okay? Now, what do we got here? What is this green line called? Not line of symmetry, axis of symmetry. And the axis of symmetry is found by using the formula x equals negative b over 2a. It is a vertical line that cuts the parabola in perfect half. What is this little blue line pointing to? The y-intercept. The y-intercept is the y value when x equals 0. That's why it's on the y-axis. What is this bad boy down here? The red. Vertex. And the vertex is found by first finding the axis of symmetry, negative b over 2a, then plugging whatever that answer was into the original function. You plug it into all the x's, and you solve for y. And that is going to give you your vertex. Yes, sir. No, you cannot just count points to find the vertex. No. Gentlemen, I am going very slowly here on purpose because, unfortunately, these are the shortcuts. There is no slope where you can count a rise over a run. There is nothing like that. You have to memorize what I have right now on the board. You have to know how to find the axis of symmetry. You have to know how to find the y-intercept. And you have to know how to find the vertex. Yes, sir.
So the y-intercept, you can't do that?
When you have an equation, sir, you have to make x equal to 0 to find the y-intercept. You cannot find the graph that I have here on the board until I find all these values. You haven't found anything here, so what do you mean you can't do it like on the board? What does that mean?
Can you find the y-intercept by counting the y?
You cannot find anything by counting up and down on the graph. No, 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 no. I'm not going to say it again. You must memorize the formulas, or you will not succeed. We're going to end right now here. Tomorrow, I am going to start off the class with a quiz. And I suggest you know what the axis of symmetry is, the y-intercept, what the vertex is, how to determine if a graph goes up or down. Tomorrow we'll finish. May God bless you. Have a great day. Hasta la vista. Have a great day and God bless.